Thanks to Vev. And I'd like to introduce the fellow that I worked with this summer, Narges Matini. She's a PhD student at the North Carolina State University, which is actually my graduate school alma mater. So we've had some lots of common things to talk about. And Narges has been a great part of our research group this summer. You can see one of our recent Zoom group meetings. She's participated and really engaged in the whole group, even though we couldn't have her here in person. So I know she's enjoyed some hiking the Appalachians this summer. We're hoping someday to get her up to the White Mountains as well. So I'll turn it over to you, Narges.
Thank you, Dr. Sayas. Hi, everyone. Thank you for listening to my presentation. This summer, I had an opportunity to work on flood-induced roadway damage risk analysis with Dr. Sayas and UCIRC. To give you an idea what my project was about, when we look at these pictures, one thing that comes to mind is when we can start using these roads again. Based on previous events, DOTs decided to open roads to traffic immediately after the water was receded, and on the surface it looked functional and dry. But what we should know is that in the underlying layers, the pavement is still weak at that time, and opening it to traffic causes significant damage that would lead to the pavement deteriorate much faster than it should. So my project was to show this problem through simulation of flooded pavement. Next slide, please. So my main findings in this study was, as you can see on the top graph, as the inundation time increases, the damage increases as well. And this shows that the inundation time plays a crucial role in flood analysis. Also, the material and the structure of the pavement has an important role too, meaning the clay subgrade is more susceptible to flood damage comparing to sand subgrade. And also, if a pavement has a better drainage system, less damage would occur. Also, as you can see on the bottom graph, I used serviceability index to determine how long a pavement is functional after it is flooded, and compare that to a normal situation without flooding and see how much life would be lost due to one flood that happens in one life cycle, and then convert that to extra costs that should be considered because pavement was failed much earlier than it was projected and planned for. And you can see the pavement that has clay subgrade fails much earlier, so it needs rehabilitation much earlier comparing to sand subgrade. Next slide, please. For future work, I think the time depth damage functions for flood analysis should be more generalized, and all the elements that are influential on flood analysis should be considered, so DOTs have complete picture and they have a complete framework to make appropriate decisions on what is the appropriate time to reopen roads to traffic. And I should say this fellowship was a great opportunity to get new experiences and learn so much more about pavement resiliency and sustainability, which is an important subject in the pavement world. And also I got a chance to improve my communication skills and expand my networking circles during all the meetings and webinars we had throughout the summer. And I want to thank Dr. Sayas for being a great mentor. It was an absolute pleasure working with her and learning from her. And I want to especially thank UNHSI staff for being involved in every step of the way, and also UCIRC for hosting my project. Thank you for listening.